Okay, a little bit more on indices, exponents. Let's say we have this question. 2 to the power of something is 64. So the question is, what exponent do we need to put on 2 to get 64? We want to express 64 as a power of 2. So 64, we're going to rewrite. 64 is 2 times 2 is 4, times 2 is 8, times 2 is 16, times 2 is 32, times 2 is 64, right? So 2 to the power of 1, 2, 3, 4, 5, 6. So 2 to the power of 6 is 64. Now this is easier, right? 2 to the power of n is equal to 2 to the power of 6. Well, apparently the exponent we need to put on 2 to get 64 is 6. So n is 6. Cool. What about this one? The exponent we put on 3 to get 1 over 81. So what exponent do we put on 3 for it to be equal to 1 over 81? First we want to write 81 as a power of 3, right? We leave this, we leave it as a fraction. 81 is 3 times 3, that's 9, times 3 is 27, times 3 is 81, yep. So 3 to the power of n is equal to 1 over 3 to the power of 4, right? Remember that a number to a negative exponent was equal to 1 over that same number to the exponent, but positive. So we could rewrite this, actually going backwards, that would be right. We could say this was originally 3 to the power of negative 4, right? 3 to the power of n is equal to 3 to the power of negative 4. This is 3 to the power of negative 4. So in this case, n is equal to negative 4. Let's do another one. Say the exponent we're looking for is not just expressed as n, but it's, say like this, 5 to the power of n plus 1 is equal to 125. Does that make it more difficult? Really? Let's see. The unknown is in the exponent on the 5, so we can't do much here. We can change this to, we can express this as a power of 5. So we just leave this and try to express this as a power of 5, which we can do. 5 times 5 is 25, times 5 is 125, right? So 5 to the power of 3. That means 5 to the power of 3 is 5 to the power of n plus 1. So n plus 1 is 3, so n is 2, right? Another cool one, 2 to the power of 2n minus 1 is 32. The unknown is in the exponent on this 2, so we're going to leave this. We're going to change this to a power of 2. To the power of 2n minus 1. 2 times 2 is 4, times 2 is 8, times 2 is 16, times 2 is 32. So 2 to the power, I just rewrote 32. 2 to the power of 5. This is still 32, right? But expressed as a power of 2. 2 to the power of this equals 2 to the power of that, so this and that must be equal. 2n equals 6, and apparently equals 3. Okay, have fun with problems just like this.